Hey, how's it going guys? Phil here, and this is a review for the ToAuto Pyramid A1.1 3D printer.
I'll first show you how to assemble the printer, then walk you through software setup, filament loading, leveling the bed, and printing for the first time. There are a lot of parts, so I'm not going to go through them all, since they're listed in the instruction manual and clearly marked with numbers. For example, this is the printer base, the aluminum profiles, Z-motors, and so on. The only parts that are not labeled are the tools, like the spatula, SD card reader, cables, and Allen wrenches. Feel free to skip ahead using the index in the description. To start assembly, begin with parts 1 through 5, these here, plus the printer base. First, take part 2, the 2 aluminum profiles, and 4 of the M525 screws in the bag marked 3. Note that the manual here has a typo that lists the screws as M425. However, M5 is the correct one. These aluminum bars will be your Z-axis guides, and take note that there are 2 threaded holes towards one end of the bars. The bars also have 2 threaded holes at both end faces. We'll be attaching the guides here on either side of the printer base, like so. Make sure to keep the 2 threaded holes at the bottom. The bars will line up with the 2 holes in the rail on the bottom here, and we'll be attaching them with the M5 screws from the bottom. Again, note that the 2 threaded holes on the face are towards the bottom side of the guides when installing. You may find it easier to lift or turn the printer on its side in order to fully tighten the screws, using one of the included Allen wrenches. All the Allen keys that you'll need for installation are included with the unit, and we'll do the same thing on the other side. Next, take the 2 Z-axis motors with couplings and 4 M420P screws from the bag marked 5. We'll be attaching the screws through the holes on either side of the motors, and using the holes on the Z-axis guides, but on the back side, so make sure you don't attach them to the front. This is why we needed the Z-axis guides with the threaded holes at the bottom. Do the same on both sides. When you're done, it should look like this. For the next step, find the X-axis guide bar marked 15. One side has a pair of threaded holes about 3 inches from the end and right at the tip, and the other side has 3 evenly spaced holes. On the back, you'll see that one hole on the right and one hole on the left has a larger cutout around it. That's so it can accommodate the bolt head on the X-axis brackets, and they'll fit together like so. We'll be using 2 M416 screws from the bag marked 6, and they'll go in the holes here. After lining them up with the holes in the X-axis bar, go ahead and stick the Allen wrench through the hole at the top of the bracket so you can tighten them. Now, lay the X-axis guide with the wheels on the bracket facing up. Next, take the belt in the bag marked 9, and note that it has a smooth side and a toothed side. We're going to lay it in the channel on the X-axis smooth side up, teeth on the bottom. This is so the teeth will be able to grab the gears on the bracket you just installed. Now, holding the X-axis with the motor bracket to your right, pick up the X-axis motor attached to the printer base, and hold it with the wheels facing you. Place the first wheel of the motor into the track on the guide where you laid the belt, with the belt extended out. Then slide the motor over the guide into the tracks on the top and bottom. It should roll smoothly on. Now take the X bracket marked 10 and line up the head of this bolt with the cutout on the bar. We'll use these 2 holes to attach it, again with the M416 screws marked 4. Then tighten through the access hole on top. Okay, so I'm going to turn this assembly around, and we're going to attach the belt bearing marked 11 at the end of the guide. The 2 pre-installed screws here have a special T-slot nut on the back that will grip the inside of the guide bar channels. You'll want to slightly loosen these nuts first. Notice that the nuts are shaped to fit inside the channel on the guides. You can align them vertically or horizontally, and either way they'll slide into the channel. Now loosely tighten the screws so that the bearing still has a little bit of play to move in or out. Next, we'll take the two loose ends of the belt and secure them to the X-axis motor. What you want to do is slide the belt into the slot on the bracket so that the metal clip at the end holds it in place. You'll go under the bracket and through the slot like so. Make sure the belt is placed over the gear pulley at the end. Then do the same on the other side, sliding the belt into the slot on the X-axis motor's bracket. Now if the belt seems loose, move the belt bearing out to ensure that there is some tension on the belt, but not so much that the belt feels stretched. Then tighten the nuts to secure the bearing in place. Next, take the part labeled 12, the end stop cover, and its two included screws. Attach them over the geared bearing on the left bracket. For this next part, you may need to carefully snip the zip tie holding together the bundle of cords connecting the base to the X-axis motor. Be careful not to cut any of the wires. Now take the X-axis guide bar assembly, and with the motor facing the front of the printer, place the brackets over the Z-axis guide bars. Line up the wheels with the tracks and firmly press down. The bar should roll smoothly down the rails. Make sure when you do this, the wires end up at the back of the machine. Now, find the top bar labeled 16 and the remaining 4 M525 screws marked 3. You'll want the side of the bar with the larger drill outs for the threaded holes on top. This bar will be attached to the top of the Z-axis guides. Part 17 are the ball screws, which are 2 long threaded rods. You'll also need Part 14, the fixing brackets, which each have 2 T-nuts, Part 35, plastic end caps, and Part 18, the Z-limit stop switches. Note that the stop switches have the T-nuts on opposite sides, since one goes on the left-hand side and the other goes on the right-hand side. The fixing brackets also have a top side with 2 screws visible, and a bottom side, which has these 2 square openings. I'm going to turn the unit around so you can see what I'm doing, since we'll be working on the back side. Thread the ball screws into the red brackets on the X-axis guide by turning clockwise. Then continue to screw them down into the coupling on the Z motor about ½ an inch or until it doesn't go in anymore. Then tighten the nuts on the coupling. If you're having trouble getting the ball screw into the coupling, loosen the top screw on the coupling first and try again. Then do the same on the other side. At the top, place the fixing bracket over the ball screw. Then slide the T-nuts into the channel on the guide horizontally before tightening the screws and securing them in place. The T-nuts should rotate and lock in vertically as you tighten. Next, take the end caps and install them at the ends of the top bar. It doesn't really matter in which orientation they're installed. With the Z limit switch, note that the T-nuts are on the shiny side of the plastic. These will slide in vertically on the Z-axis guides, and the switch should face the front of the unit opposite the side the motor is on. Then tighten the screws and do the same on the other side. For the last part of the assembly, you'll need all the remaining pieces. We'll start with the 4 pull rods marked 27. These rods are threaded at both ends, and we'll need the 2 headless M640 bolts marked 23. Choose any rod and screw in a bolt at one end about halfway. Then take a second rod and thread it onto the same bolt so you end up with one long rod. Do this again with the remaining 2 rods. Now take the 4 M635 eye bolts labeled 24 and the 4 M6 hex nuts labeled 20, and thread one nut onto each eye bolt, stopping about a ½ inch or 1 centimeter from the eye. Thread one bolt into the holes at both ends of each pull rod. You'll want to make sure that you've left enough room at the ends of these bolts. If necessary, you may need to take them out a bit. Next, take the flat brackets marked 26, connector B, and note that there are 3 holes, a single hole at one end and a pair of holes closer together at the other. We're going to use the part labeled 21, M510 screws, to attach the bracket through the eye to the outer hole in the 2 that are close together. Then attach the second bracket to the other rod in the same manner. On the opposite ends of the rod, we'll be attaching part 25, connector A, which has 2 holes on one side and a single hole on the other. The outside of the single hole will be attached to the eye bolt using the M5 screw. Next, we'll need the M4 8 screws labeled 19 and the M4 T-nuts labeled 22. And we'll be attaching 2 each to all 4 brackets. Make sure all the screws are on the same side, and the T-nuts will be attached on the reverse side with the grippy side facing down. On the L brackets connector A, the nuts go on the outside. Now, position the pull rods with the flat bracket at the bottom facing out and the L bracket on top facing in. If the brackets don't reach the guide bars, loosen the eye bolts to increase the length. Then fix the screws on the bottom with the T-nuts inside the rail track and the bracket all the way to the front of the unit. At the top, fix the L bracket with the T-nuts inside the rail along the face of the top bar. Orient them horizontally to get them to slide inside the track. Again, they should turn vertical as you tighten, but if they don't, you can give them a nudge with a small Allen wrench. Then do the same on the other side. Now take the material rack, part 36, with the T-nut and screw pre-installed, and set it into the track on the top rail, and tighten the screw to secure it in place. Next, we'll install the filament sensor, part 13, which will be installed with the arrow pointing down and the 2 screws pre-installed at the bottom. It'll attach here to the X-axis motor. If you haven't already, remove the styrofoam cushion under the heat bed. Then, locate the power connector cables on the sides. Note that there are 2 connectors, a narrow one and a wide one, both marked Z. The smaller one will connect on the bottom of the Z limit switch, with the 2 catches facing the outside. The wider connector connects to the right-hand side of the Z-axis motor. So if the connector doesn't reach, you can separate the cables to give it more length. The ridges on this connector will face up when being plugged into the slot on the side of the motor. On the other side, the Z-axis motor connector is easier to access since it's on the outside, and the small Z connector goes into the bottom of the switch on this side. The power cable marked X will attach to the bottom of the X-axis motor towards the back, and the connector marked filament detection goes into the connector on the side of the sensor. Don't forget to remove the foam pad under the bed on this side too. On the back of the unit, the power supply has a switch here marked with a yellow sticker for you to select your region's supply voltage by sliding this tab. In the US, set this to 115 volts. Lastly, we'll remove the plastic film on the LCD screen and the glass plate. To do this, remove the binder clips, but don't discard them because you'll need those to reattach the plate afterward. Now we can plug in the power cable and switch the printer on. You'll see a boot screen on the LCD, then a menu. But before we print anything, let's check out the bundled software on the included SD card, which you'll find plugged into this USB card reader. Pop that into a computer or laptop, and here's where you'll find Cura, a free 3D modeling and printing software, video instructions for assembly, bed leveling, and included parts, though these are technically for the previous printer model. The model folder has some 3D design files, including several replacement parts for the printer itself, like the filament sensor bracket, and 2 G-code files which provide direct instructions for the 3D printer to make a print. You can go ahead and install the Cura software, but note that it's version 4.2, and if you want the latest version, you'll need to download it from Ultimaker's website for free, which is what I'll be doing. While it's installing, I'm going to connect the printer to my computer using the included USB-B cable. After launching the software, there's a few setup prompts and Cloud Account login, which we'll skip for now. Then choose Add a non-networked printer, and in the list here, near the top, just under Ultimaker, select Custom and Custom FFF Printer. I'll name it Pyramid A1.1. Then in the settings, use the values provided in the manual, 310 for X, 310 for Y, and 400 for Z. I'm also going to check Heated Bed. Then check the Extruder tab and enter 0.4 for nozzle size and 1.75 millimeters for material diameter. Then click Next. From here, go to the Preferences menu and choose Configure Cura. Select Profiles from the menu on the left, and then Fine from the listed profiles. Then go to the Import tab, and on the SD card, go to the Profile folder, and select the profile provided. Here, it's ELF 4.2.1. Click Open, and you should get a successful pop-up. Click OK. Then choose the new profile from the Custom Profiles list, click the Rename tab, and change it to Pyramid 2.1. Click OK, then close the menu. Now the software should be set up to send prints to your 3D printer. But before we do that, let's load up the filament and level the print bed. First, take your filament and snip the tip at a 45-degree angle so that you get a point. This will allow it to feed into the extruder more easily. We'll hang the filament roll on the material rack. I like to load my filament with the X-axis motor centered. So on the LCD screen, I'll select Leveling, then 0.5, which will move the extruder to the middle of the bed. Then I go to the Move menu, set the increment to 10 millimeters, and move the Z-axis up 20 millimeters. And that just gives you a bit of space under the extruder for material to come out. Then insert the filament into the sensor, and feed it down into the extruder. You'll want to use the thumb handle to pull out the side in order to get the filament down past the silver gear. Then on the LCD screen, go into Settings, then Filament, then tap Load, then Confirm. If your extruder is preheated already, it will load right away. Otherwise, you'll have to wait till it heats up first. But when it's done, the filament will be pulled into the extruder, and some will squeeze out the bottom. So you should remove that before you start printing. To level the bed, press Leveling on the main menu, then select 0.1, which will move the nozzle to the front left corner. Then you'll want to turn the adjustment wheel under this corner to lift or lower the bed, clockwise to raise it, counterclockwise to lower it. Using a sheet of printer paper, you want to adjust the bed height so that the nozzle, at 0.1, just touches the paper. So here, I'm going to raise it a bit. And if I slide the piece of paper, I can get it under the nozzle. but also feel that the paper is scraping up against it without getting stuck. Then move on to point 2 and do the same. Repeat this process for all 5 points, 1 in each corner and in the center of the bed. If the center point isn't right after leveling, repeat the process for the 4 corners until the paper slides freely under the center point. Okay, now we're ready to load up a 3D model to print. I've got one downloaded here for a custom board game piece for Candyland, since we lost one of ours. And to print it, just click on Slice in the bottom right-hand corner, and you can save the model to the SD card as a G-code file and print it directly from the 3D printer, or click the arrow here and print via USB, which we're going to try now. It'll estimate how long the print will take and how much filament you'll need by weight and length. So that's 4 grams, or about 1.5 meters of filament, and it'll take about an hour to complete. So now we click Print, and the heat bed will start to preheat. And you can see that there isn't a temperature set yet for the extruder, which preheats automatically after the heat bed comes up to temperature. And once that's done, the printer will start printing automatically. Alright, there it goes. Now you can hear the fan running for the power supply. It's about as loud as a computer fan running with full processing power. But the motor noises for the printer are pretty minimal. This print will take about an hour, so we'll check back in a little bit. Alright, so I forgot that my laptop goes to sleep after 15 minutes. And if you're printing via USB, it's imperative that your computer stay on, otherwise the print will stop, and the hot nozzle will melt part of your print if it stays in one spot too long. Luckily, it wasn't stopped for too long, and once I woke the computer back up, it resumed printing. But if you want to avoid this problem, make sure to disable sleep mode on your computer or laptop. Or you can also print directly on the printer using a G-code file loaded to the SD card. This is the completed Candyland piece, and as you can see, it's not perfect. There are a couple hairy strands that came loose, and you can see that it's mostly at the end of the ponytails here on the figure. And this actually has more to do with the design of the model than it does the performance of the printer, since these 2 spots called overhangs aren't supported by any structure beneath them. It's a notoriously tricky thing for 3D printers to get right. Also, you can see the melted blob where my print had stopped for a few minutes, and it seems to have skipped a layer when it resumed. So the structure there might be a little weak. The lesson here is, don't let your printer get interrupted by sleep mode. You might also have a little trouble getting your print unstuck from the heat bed after it has cooled down. That's where the included metal scraper comes in handy. You can use it to gently wedge up around the edges to release your print without damaging it. And I'd say the print isn't half bad considering. Let's try out one of the included print files on the SD card. Insert the SD card into the slot just below the LCD, then select Printing. Go to the Model folder, and we'll try out the rabbit model that's there. After preheating the bed and extruder, the print fires up right away. You can also choose to preheat these in advance using the Preheat menu. Just remember that all temperatures are in Celsius. Occasionally, while printing, you may hear the printer vibrate. As the print head moves back and forth quickly. While this could affect print quality if severe, I didn't find that it had any impact on this particular print. If you're concerned about it, you can dial down the speed of the print in the options to avoid some of the quick, sudden movements that cause vibration. Just note that your print will take longer to complete. When the print is done, the bed will move towards the back of the machine automatically. You can see here that the print took about 2 hours to complete. As tempting as it may be to remove your print right away, you should wait about 10 minutes for the bed to cool down to room temperature before you attempt to detach your print from the bed. You can see that there's a bit of stringiness towards the end of the print where the extruder had to move over the gap between the ears, but it's not too bad and these extra strands and bumps can be removed by trimming or sanding. Upon close inspection, the print overall is very good. It has nice smooth transitions with zero ringing or ghosting. Here we see a tiny bit of extra material, but that can be trimmed. And you can see the adhesion of the print towards the back lifted just slightly, but that doesn't seem to have had a big impact on the overall print structure. And despite the occasional vibrations I saw during printing, it doesn't seem to have manifested as flaws in the print, so I'm pretty happy about that. After printing, you'll want to unload your filament by going into the same menus as you did when loading. Then carefully pull the filament out of the extruder once it's been backed out of the nozzle. Be careful not to pull out the collet in the extruder, which tends to pop out during filament removal. You can just press that back into place. Always remember to store your unused filament in an airtight plastic bag to keep it from absorbing too much moisture, which could negatively impact your print quality and filament performance. Overall, I'm pretty happy with this printer. It was easy and straightforward to assemble, works well with the bundled software, and the prints are fast, clean, and accurate, as long as the model file you're using is designed well. The menu interface is very simple to use and understand, but doesn't have a lot of advanced features or settings, which makes this unit a really good one for beginners to learn the basics of 3D printing. More advanced users may want more control over their prints, and there are some upgrades you can perform to enhance this machine later on, like changing from a belt to direct drive for the Y-axis, or adding an auto-leveling sensor like the BL Touch. It's able to handle a variety of filament material types like PLA, PETG, TPU, ABS, and carbon fiber. The maximum print size that this printer can create is 300 by 300 by 400 millimeters, or roughly 12 by 12 by 16 inches. I hope you enjoyed this review. You can ask me any questions in the comments. I'll put a link to the product in the description below. Don't forget to subscribe to my channel, and join me next time.